in the virtualization, the last section, distributed resource scheduler. So today we are going to discuss about what is a DRS and what are the different forms of DRS. So there are manual, partial, and fully automated DRS are there. So before going to the DRS, so let's understand what is a DRS. We had been knowing about the load balancing and the VM going from here to there, from this host to that host. So when we are building up the virtualization platform or cloud platform, and then we are having multiple hosts, and we are having multiple hosts also to do the load balancing and also many times the fault tolerance, etc. So in that case, the DRS is a feature of a cluster. That means DRS is useful when we have a cluster of hosts, which is been virtualized and they are acting as a cluster. And this cluster is managed by the vCenter server. In few lectures before, we have seen what is a vCenter server. So vCenter server manages multiple hosts, and multiple host means multiple virtualization VMware clusters. So what it does, it balances the load of virtual machine across different ESXi hosts. ESXi is a hypervisor of a VMware. So it balances the load of VM. So when we enable the DRS in the VMware cluster, so if the DRS is enabled for the cluster, it does three tasks. One is a initial virtual machine placement. So when you create a VM and a DRS is enabled, the DRS is going to decide this VM is going to be placed where. And then it also does a load balancing. So load balancing architecture, etc., we have seen it. But to understand it, let's say we have multiple hosts. Let's say we have this multiple host, this EXI host 1, EXI host 2, EXI host 3. And we have made them a cluster and we have enabled them a DRS, the distributed resource scheduler is enabled. Now, if in one host, we have two virtual machines, and let's say the load in this host is 40%. And in another host, the load is 80%. It has 3 VM and load is 80%. Now in the third host, the load is 20%, right? Now, in this case, if the DRS is not enabled or DRS is not used, what will happen that all these hosts will keep on running. And this host is going to consume the energy and everything, and the capacity is only 20%. But if we can shift this load to here in this host, then this host load will be 60%, and we can close this cluster. So in that case, better utilization of resource will be possible. And that is the job of the DRS. So DRS is actually helps in balancing the load across the EXI cluster. And if we don't have a DRS, then this balancing of the load will not be possible in the VMware. So the main goal of, if you will go here, so the one thing is that it did the virtual machine placement. The other one is load balancing, as we saw it in the next slide. And it also does the power management. Now, how the power management is useful? So let's say we have in the daytime when the activity of a company is high, and that time there are 10 clusters are there, and the load in all the clusters are around 80%. But as the office hours finishes like 4 p.m. or 5 p.m., that time the load from these clusters goes away, and maybe they are only been working 10%, right? Let's say we have 10 cluster and the load is only, every cluster has 10% load. And if we do not do any kind of load balancing, then this 10 cluster will keep on running with only the 10% utilization, and which is going to consume the power and also all the other fixed expenses to maintain the system. Now, if there is a way to either one person sits and shifts the load from one VM to other clusters, or there is an automatic way where this automatically it will decide that, okay, yeah, the load is less, and now we can switch the load from one place to other. So now in this scenario where 10 clusters and all of them is utilizing 10%, it is a possibility that all the load can be shifted to one cluster or two cluster. And in that case, remaining 8 cluster can be shut down for the whole night of around 15 hours. So 15 hours of power power consumption will be saved. And that's why DRS has, important to note, if a question is asked, what is the functionality of DRS as per the resource management? Then 3 things need to be written: initial virtual machine placement, load balancing, and power management. So next we go, depending on how end users are using the application on a VM, the VMs can constantly expand and contract. So DRS has also a task that if the load has already reached the capacity and more VM, like in the last case, we said that from 10 cluster at night, the load is maintained by 1 cluster or 2 cluster. And in the daytime, when the people come in the office and then the more VM is needed, then the DRS automatically will initiate the cluster, restart another cluster, and start placing the VM there. And then if load goes further, then it can start the 5th cluster. So that's why it can expand. And when the load is not needed, it can contract. And it can do automatically for week or month if fully automation has been enabled. In this case, the physical host becomes overutilized or underutilized based on the VM utilization and the number of VM running over it. So one thing also important to note that to enable DRS, one should also have to enable the vMotion of VMware. So here we are talking about DRS capability of VMware. So in case of VMware, if you want to do the distributed resource scheduler, the vMotion has to be enabled as well. That is one of the requirements, because vMotion, as you know, that it helps in the live migration of VM from one system, one host to another host. Remember, in the last lecture, we have seen that vMotion can help in the live migration, and the downtime is very limited in case of vMotion. Now, the main goal of DRS is to keep all the EXI server in the cluster healthy and well utilized by dynamically and automatically moving VM across EXI host. So one question has been asked that, does VM moves? The VM, if you ask me what is a VM, so VM is basically a box in which the different installation, the OS and other thing has been installed and different task is running. Now, from one host to another host, the moving VM means actually moving the image from this to this. It's not that we shift the whole hardware to there. It is what is the state in one host that has been recreated in the another host. And this, the image will be removed. In a nutshell, not image. For VM case, we don't say the image, but we say the VM condition. So what it does that. It is going to keep the different server healthy. Sometimes server may go down. In that case, the one need to move the VM from one server to another server, so that VM can be replaced or can be repaired. So it helps in keeping the server utilized optimally. And it also provides the VM with enough resources all the time and keep them running in the best possible way. With the DRS, the downtime is absolutely zero. So if a DRS is enabled, then the zero downtime will be there for server maintenance. In olden days, when we were working on the server, and often the server has to be at night time, the servers are used for maintenance and they are closed. But in current condition, if you are using DRS kind of ability, then the downtime of server maintenance will be zero, because whatever task was running in one server can be moved. And if you see there, because it is working in a cluster, so storage are also virtualized and they are using a shared storage. So anything, if I close it, whatever is condition was here, I can simply shift it. The storage can be redirected here, whatever it was using. All the storage don't need to move, only the VM condition has to be recreated there. So this way, the downtime of zero downtime can be maintained. And by default, how it does, so DRS, the vCenter server is there, that is going to check all the time, every 5 minutes, that what is the workload, and workload is balanced or not. So every 5 minutes, if this time is not changed, by default in VMware, the DRS check time is 5 minutes. We can change it to 1 minute or even longer, 15 minutes, 30 minutes. But by default, 5 minutes is there. So every 5 minutes, it is going to check in the cluster whether the workload is balanced or not. And if the workload is balanced or not balanced, then it is going to do its action. If it is not balanced, then it will try to balance the workload across the cluster. And if it is remain balanced, then it is going to check after 5 minutes. Is that okay? Is that okay so far? Okay, thank you. The topic is very simple. I'm going slow so that in case you miss certain point, certain important point I'm telling, and that can be helpful in preparing for your exam. Okay. Now, what are the different type of DRS are there? So there are 3 types of DRS. The one DRS is manual one. So when we when we are enabling the DRS, there is a settings where 3 options can be chosen. If we say manual, then the DRS cluster is set to manual. Then every time we have to power on the VM, and cluster will prompt you to select which EXXI host you want the VM to be hosted. That means if we keep the manual DRS option on, that time it is not going to do initial VM placement, nor it is going to do the load balancing, and nor it is going to do the power management. Sometimes the manual DRS option is needed. So in case of manual DRS, when we power on the VM, then it will ask which EXI host you want to put it. And when we are paying the money for the DRS feature and so expensive, then why to use manual? Manual is used only for some kind of check or some other kind of option. Sometimes manual DRS is needed, so manual DRS is used. But most of the time, around more than 80% of the time, manual DRS is not being used. Now the next option comes is a partially automated DRS. If we select the partially automated DRS settings in the DRS automation settings, then it will be automatically decide which host, a VM should be running. That means whenever we power on the VM, so it is going to do the initial VM placement. So if my partial automated DRS is done, then we say power on VM. Let's say VM name is Dilip Prasad, and we say switch on or power on the Dilip Prasad. Then Dilip Prasad VM is going to be powered on, and the DRS will decide, okay, he is going to be placed on the EXXI host, which has been kept at Bodo. And though I am in Tromsø, but the Bodo EXXI host is free, so I have been placed in Bodo. So it to think like that way, but it is going to still prompt for all the migration of DRS lab. That means initial VM is automated, but migration, so when a load is going to, so I have been, Dilip Prasad VM has been placed in Bodo. Now the Bodo EXXI host is going out of the capacity. That means it is already 90% or 95% running. And that time, if partial automated DRS is enabled, then it is going to send the message to the server administrator or VMware administrator that the load has been increased, which please migrate your VM from this to other places. So migration has to be done manually. For manual DRS, everything has to be done manually. For partial one, the migration, basically the load balancing will be done manually. And you can understand that if this kind of DRS is so useful, so these two type of services mostly not used. Then when we say fully automated, then all the three properties, the VM placement, load balancing, power management, all is being done with the fully automated DRS. Now, fully automated has a drawback. It is very good functionality. It has a drawback. The drawback is that, let's imagine we have these three hosts, and okay, is anyone able to hear me well, or my voice is not doing well today? Okay, so I have to keep my direction down. I cannot be so animated. Okay. Okay, the sound was bad today. Let me check. So I will try to keep my direction of my mouth towards the keyboard of the laptop. I hope that will help today's solution. Okay. So if imagine the drawback of fully automated DRS. If we have this 3 EXXI host, okay. If we have this 3 EXXI host, and assuming that they all has 50% load, 50 here, 50 here, and 50 here, right? So if 50% load is there in all the hosts and DRS is fully automated, in that case, it is okay. It is fine with it. So no need to balance anything because everyone is having equal task. Now, assuming that this load goes to 52% and this goes to 51%, right? And this has still 50%. So what it is going to do, it will try to shift 1% load from here to here. And now 1% load is very difficult to do it because just shift 1%. So what basically it is going to do, it can only move one VM, the whole VM it can move, right? The load of the one VM it has to move. And the load of one VM may not be 1%, but since automated is there, and it is trying to move one VM from here to here, then the load here will increase to 52%, and it will again try to move to here. Then again, it is going to move here. So it is keep on moving from here to there, and that is going to cause the performance issue. If the load is perfectly balanced and slight change in the load will occur, then this to and fro, because it is a system and it has been asked maintain the equal load everywhere. So this is a drawback of the fully automated DRS. So with this, our today's discussion on DRS is done. So if you have any question on it, please ask me. Any question if you have, otherwise we take a break of. So what we were talking about, there are 3 types of DRS is there, right? And manual, we know that everything is manual. Whenever we power on a virtual machine, then the cluster is going to ask which host you want to put it. So even the initial VM placement or the load balancing, everything manually we have to do it. When partially automated DRS is enabled, in that case, when we power on the virtual machine, then it is automatically will decide which host it should be running. So whichever host has less load, it is going to shift that virtual machine to that host. But in case that particular host, the load increases, or anywhere in the system, in the cluster, the load goes up or down, it is going to prompt that load you have to balance yourself, and you have to shift this VM from this to that. All these things manually needed to be done. But in fully automated, everything is done automatically. The VM placement, even when we power on the VM, the placement of VM is automatically done on a host. And when the load changes, it is automatically going to shift the load from one host to other. But fully automated DRS has a drawback. It has an advantage, but it has a drawback is that, assume we have this 3 cluster, 3 EXI hosts, and all this host has 50%, 50%, and 50% load. Now, when we have this 50% load, right? Right. So when we have this, first time I'm using this thing. When we have this 50% load everywhere, then everything is okay. But now assume that this has 50% and this has 51% and this has 52%. The moment this situation arises, what it is going to do, it is going to shift a load from here to here, 1%, because it has to balance load equally. Now, 1% load, how to move 1% load? It has to move the whole VM. One VM it has to move. Now, one VM load may be 3% or 2%. Then what will happen? That this will become 52%. And this will become 50%. And in that case, again, it is going to start balancing it. So this load from here to there, it keep on happening. And that is going to cause performance issue and delay and disturbance in the response of virtual machine on which the applications are running. So this is the one drawback. If we enable the fully automated DRS. So I hope it is clear to you now. Is it clear now? They can avoid the issue. See, if we set the settings like do the DRS when the load is 80% or the load is 50%, then they still can sort this issue, or let the DRS act when load goes 80%. So in that situation, it can work. But in anyhow, means sometimes this kind of situation can arise when even we say 80%, and it can happen that each host has 80% load and one became 82, then again the same thing will start happening. Usually this is not a big problem. If this kind of thing happen, it's usually this is not a big problem, often not occurred, but this is one the extreme condition where the automated DRS will have an issue. They might be having a different way to manage it. So yeah, there is a percentage difference. Whatever percent difference we can set, like let's say 50%, and if the load is you manage it within 5%, let's say we say that up to 55% don't do anything. But even if we say 55%, then all the host will be if one become 56%, then 1% load will start going from there to there. Any this kind of situation can arises. Whatever we do, take care of the condition. There can be a more intelligent thing can be integrated, where it can automatically understand that particular company, how the load is getting balanced and when to really stop DRS to work. And that can be done using the AI, and AI can learn that situation, and I hope they will listen to it. This is a problem, they have not solved it yet. But this is a very good question, and this is this is one example we are learning in the VMware. But this kind of load balancings of different types situations can arise in different kind of load balancing architecture or load balancer. There are more than hundreds of load balancers are there if you go to Azure Marketplace, and every one of them is doing some job better than others. So in load balancing world, there are much more challenges are there rather than there are more challenges are there, so that there are many solutions are there. But this point the VMware should take into account. They should come up with a suitable solution and AI could be one way to understand that, which automatically will determine that what is a general pattern of the company when the load has to go and not go. It can run automatically, like in a week, if you let AI to learn it, how the load is getting balanced, and after a week, it is automatically, this issue will not occur. So any other question you have? So if no question, then we resume after